Hi everyone! I'm making this video to share something I know on math that may be helpful for you in your reviews, especially in civil service exams and other licensure exams. I have collected some questions on various reviewers so we can be familiar with different kinds of math questions. First, we should be familiar in different math basics such as the multiplication table for factors and multiples. Like the multiples of 2, which are 2, 4, 6, 8, 10. The multiples of 6 are 6, 12, 18, 24, 30, and so on. In that way, you can easily factor some large digits. Like the factors of 30 are 10 and 3 and 15 and 2. Next are the squares and the cubes. For example, the square of 1, that's 1 times 1 is 1. The square of 2, that's 2 times 2 is 4. The square of 3, that's 3 times 3 is 9, and so on. The cube of 1, that's 1 times 1 times 1 is 1. The cube of 2 is 8, that's 2 times 2 times 2, that's 8, and so on. Next are the prime numbers and the composite numbers. A prime number is a whole number greater than 1 and whose only factors are 1 and itself. That's 2, 3, 5, 7, 11, 13, and so on. 9 is not a prime number because it can be factored by 3 times 3, and these are what we call the composite numbers, or the integers which has factors other than 1 and itself. Even numbers are those integers divisible by 2, and odd numbers are the opposite. Number series is a form in which particular numbers are present in a particular order and missing numbers are to find out. Nowadays, number series is a very important part of every exam. To start, number 1. 3 times 2 divided by 3, 6 times 3 divided by 2, 9 times 2 divided by 3. What's the next answer? This is a series of operation which is ruled by the PEMDAS. Start evaluating those inside the parentheses, then the exponents, and multiplication and division from left to right, then addition and subtraction from left to right. As we can see, the first digits has a pattern that is in the multiples of 3, 6, and 9. And look at the next digits where 3 and 2 is changed in every other set. That's 2 divided by 3 and 3 divided by 2 every after set. From here, we can identify that the next set should be 12 times 3 divided by 2. Now, using the PEMDAS, we can already perform the operations. May I remind that this does not mean that multiplication and addition should go first before division and subtraction respectively. This means that in any set which has multiplication and division together or addition and subtraction together, perform the operations from left to right. So 12 times 3 divide 2, that's 12 times 3 is 36 divided by 2, the answer is 18. Now, the first digits has the pattern of squares, square of 1, 2, and 4. The missing digit is the square of 3. And just like earlier, the operations between the digits are changed every after set. That gives us the missing solution of 9 divided by 1 times 2. The answer is 18. Next question, 12 is 60% of what number? In a percentage question, this is the standard situation. A whole number multiplied by a percentage is a number. So since the number is already given, we say whole number times 60% equals 12. We divide 12 by 60% or 0.60. The answer is 20. A reminder of evaluating decimal number, let's say 0.3 times 75. Perform the normal multiplication, that's 2250. In placing the decimal point, count the number of the decimal places, that's 1, 2, so the answer is 22.5. Another example is 0.05 times 65. Perform normal multiplication, the answer is 325. Count the number of decimals, so that's 3.25. Another 75 divided by 1.25, so you move 2 decimal places to the right and then perform normal division. What is 2 and 1/2 subtracted from its reciprocal? There are 3 types of fractions. The proper fractions, when numerator is less than the denominator. Improper fractions, when the numerator is greater than the denominator. And mixed fractions, which consist of a whole number in a proper fraction. In changing a mixed fraction into an improper fraction, multiply the denominator by the whole number and then add the numerator. So that's 5/2. To check, let's divide 5 by 2. So the answer is the same, 2 and 1/2. Another example, 3 and 1/5, that's 5 times 3 plus 1, that's 16/5. Let's check, 16 divide 5, that's 3 and 1/5. Let's go back to the question. 2 and 1/2, that's 5/2. Then subtract from its reciprocal, that's 2/5. Get the LCD, then subtract. 4 minus 25, that's -21/10. Square root of 150 minus square root of 54. First, identify if the radicands have factors which consist of a perfect square. 150 has factors of 25 and 6, and 54 has a factors of 9 and 6. Since 25 and 9 is a perfect square, take that one out to its square root. That's 5 square root of 6 minus 3 square root of 6. You can directly add similar radicals. That's 5 minus 3, that's 2 square root of 6. Next, 3 square root of 8 plus 5 square root of 2. Again, factor it out. 8 has the factors of a perfect square 4 and 2. So it's 3 times 2 square root of 2. Add similar radicands. That's 11 square root of 2. Take note, you cannot add dissimilar radicands. Next, which is the largest of the following? 3/10, 1/3, 5/14, 10/27. Transform these fractions into its decimal form by dividing the numerator by its denominator. Now let's see which of these decimals have the highest value. So it's 0.37. The answer is 10/27.